In this session, we saw that design and testing of analog circuits. With this, previously we have seen that low pass filter. Now we are going to check the high pass filter. High pass filter, by using RC components, we are going to construct the circuit based on this circuit diagram. The components integrated into the breadboard. This is the input terminal which is coming from the function generator. It is given to the our input points. The capacitor first end goes to the positive, and in the fall of that resistance is connected. The resistance second end connected to the some other alternate breadboard ports. The input connected to the capacitor first end and the resistance second end is connected as a negative terminal. The output is taken from capacitance second end and the resistance first end, which node it's connected together from the particular point. Your output positive is taken. The ground, so already is a common one. So from the common ground itself, it's taken to the output device. So here the name itself, we are going to see that high pass filter, which means it will allow only the high frequency signals. So alternatively, it could not allow the low frequency. For seeing that, initially I set it in the range of 1 Hertz, by default VPP of 5 VPP. Now I enable the input. So now the input is enabled, it is feed into the circuit. In the output terminal, we cannot able to see any output as a VPP, because in the output DSO we already customized 1 square will be 5 VPP. As per the output, it shows it's a 0 VPP. There is no output signal reaches from the circuit. From the circuit, input and the output is connected. Now the input is enabled. The input is given to the circuit. As per the output, there is no output reading through the DSO. So now we are going to increase the frequency gradually in the function generator in the range of Hertz. So now it is increased more. It's increasing. Still now our VPP get gradually increased, that we can able to see through the DSO. This data points we have to note down in the graphs. Our input frequency, output VPP from DSO. So we started from 0. See, we started from 0, gradually we are increasing the frequency, the range of 5, 10, 15, 20. So until the maximum VPP we are obtaining into the output points. So initially for the 0, output VPP will be remain 0. So like that we are increasing the frequency. So we are gradually increasing. So our output terminal is gradually increasing the range of 1.2, 1.4, 1.8, 2, 2.2. So like that increase, we have to increase the frequency level up to the our set VPP of 5 VPP. When it reaches the 5 VPP, have to stop. So now it is approximately, our output shows as a 5 VPP, the frequency range of 573. So now our output clearly shows we are obtaining the value of 5 VPP in the range of 1.0 kilohertz. We are obtaining output in the range of this frequency level. Now we are going to calculate our component values with the following equation. Here our R value will be 1 kilo ohm, C value will be 1 microfarad, frequency we have to calculate the following equation. Frequency we have to find out through the following equation. This is the theoretical value we have to find out. With the theoretical value, as per the practical value, with the theoretical value, we have to compare with the practical value which you are obtaining through the laboratory setup. These two we need to be compared by plotting this graph. We can able to obtain the frequency curvature level for the high pass. Set our frequency, X will be our frequency, Y will be our amplitude, VPP. For the high pass, for the 0 frequency, our output VPP will remain 0. As per our input data, as per our input and output data, we have to plot the graph. Our graphical plot points will be like that. Finally, we make the straight line with the data points. Our graph will be like this, which means from the initial stage for the high pass filter, for the low frequency, the output remain will 0. When you are increasing gradually the frequency level, our output VPP also will get gradually increase. With the particular certain stage, it will maintain the constant VPP and will remain same until the any higher frequency. With this, we have to make the straight line points like this. Which point is crossing, that is our FC, the frequency. From this value and this value and the theoretical value, we have to match. With that, we can able to find the cutoff frequency of the high pass filter. So this is our laboratory setup for the high pass filter RC circuit. This is our circuit, it's our input device, this is our output device. The input output is enabled, we obtain up to output graphical points like this. So from this we found out the high pass filter cutoff frequency range for the our input analog circuits. That's it.